In Module 2 of Chapter 10, we're now going to generalize this one-period model. So the question is, how do we determine how many shares, well, that was the delta you may recall, and B will be the notation of the T-bill position. So in the earlier examples in Module 1, we needed two parameters to replicate the option. One was the number of shares, the delta, and the other one was the T-bill position, which we're now going to denote B. So we're going to assume that we have a stock that pays a continuous dividend. So we'll generalize our model a little bit. And we'll assume that as continuous dividends are paid, they're reinvested instantaneously in new stock. So we've seen this before. If we buy one share at time t plus h, we're going to have more than one share. Namely, we're going to have e to the delta h shares. We'll have a period of length h, and our interest factor for T-bills will be e to the RH. Typical accumulation factor, e to the minus RH when we're buying T-bills. And then we're going to generally say that S0, the initial price of the stock, goes up to US0 or DS0. So U is 1 plus the return in the upstate, so-called upstate, where the prices go up, and D is 1 plus the return in the downstate, namely where prices go down. So in our general picture, we have our stock price tree. S0 goes to U times S0 or D times S0. And in a later module, we'll think a little more about where U and D come from. Corresponding to that, we have a tree for the option value. CU is the exercise value. We're dealing with an European option, and it's the exercise value when the stock price is worth S times U. And CD is the exercise value of this option when the stock is worth S times D. So this is, of course, what we're trying to determine. We're trying to determine C0, right? What's the price of the option today? So we're going to model the portfolio as we did before. It's going to be a combination of delta shares and B dollars and T-bills. So this is the price at time H. So we buy delta stock. The cost is delta S0, and we buy. So the cost of this portfolio, just to be clear, is delta S0 plus B. That's what we buy, right? Because we're going to buy delta shares of stock at a cost of S0 each, and we're going to buy B dollars of T-bills. At time H, our delta shares change value because the stock will now be worth SH instead of S0, and of course we earn interest on the T-bill. So what we want is we want our portfolio to equal to two option prices. In the upstate, if we go back to the general formula, the price at time H is delta times the value of the stock at time H. Well, notice that the value of the stock has two components. We have a price appreciation in the per share price. Per share prices go up by U, but then we have this factor reflects the additional shares we bought with dividends. So when the initial stock price goes from S to US times e to the delta H, it's important to recognize there are two things going on here. One is we have price appreciation per share, and then we have extra shares purchased with dividends. So this total position must be equal to the exercise value of the option in the upstate and the correspondingly in the downstate. We can solve for delta, and we get these two formulas, which we'll see time and time again, that the delta of the option is the present value at the dividend rate of the relationship between call prices and stock prices. And we can see that the value of the T-bill position is the risk-free present value of this term. Now notice that we can predict when delta is positive versus when it's not negative. Delta will be positive anytime CU is bigger than CD, namely when the exercise value increases with stock price. So that would be typical for calls. Calls have positive deltas. But what if C, to abuse notation for a minute, was the exercise value of a put? Well, CU would be smaller than CD, and the delta would be negative. So we can see from this formula that calls should have positive deltas and puts should have negative deltas. And we'll see that is true.